So let us look at these questions. So the first question is based on the concept of ordered pair. It's given that ordered pair 2x plus y comma 5 is equal to ordered pair 3 comma 3x plus 2y. If these two ordered pairs are equal, then find the values of x and y. So the concept is simple. If two ordered pairs are equal, the x and x, the first numbers should be equal as well as the second numbers have to be equal. That means 2x plus y has to be equal to 3 and 3x plus 2y has to be equal to 5. Both these conditions have to be valid. So now you have two linear equations. You can just solve the linear equations. So let us multiply the first equation with 2 and let me subtract one from the other. 2y and minus 2y gets cancelled. 4x minus 3x is x is equal to 3 into 2, 6 minus 5 is 1. So x is equal to 1, and if you put x is equal to 1 here, y has to be equal to 1. So the answer to this question is x is equal to 1 and y is equal to 1. A very simple question. Next question is, A is the set 1, 2, 3 and B is the set is given in set builder form, x such that x is a prime number less than 5. And you're asked to find n of A cross B. So what is the formula that we have? N of A cross B is equal to n of A into n of B. N of A is clearly 3. N of A cross B is equal to n of A times n of B. So n of A is already equal to 3. B is not given in roster form. I cannot directly get n of B. I need to write this in roster form. So what is the corresponding roster form? B is equal to x such that x is a prime number less than 5. How many primes are there which are less than 5? So 2 and 3 are primes less than 5, right? So this is the roster form for B. So how many elements are there? There are 2 elements. So 3 into 2 is equal to 6. So n of A cross B is equal to 6. So in this question, you're given the sets A, B and C. And you're asked to find A into B intersection C, number of elements in A cross B union C. Again, very straightforward questions. So A cross B intersection C is nothing but A is the set 1, 2, 3 cross B intersection C is nothing but the intersection of B and C. So what is the intersection of B and C? So what are the common elements of B and C? You have only 4. So A cross set 4, right? That is equal to set 1, 2, 3 cross set 4. So once you multiply two sets, you get a set containing ordered pairs such that the first elements come from the first set, the second element comes from the second set. So you have 1, 4, 2, 4 and 3, 4. So this is my A cross B intersection C. There are 3 elements in this set. Now let us try to find n of A cross B union C. So what is n of A cross B union C? That's nothing but by formula n of A into n of B union C, right? So what is n of A? N of A is very clear, which is 3. Now n of B union C, I need to union these two. What is B union C? Is nothing but 3, 4. 4 has already come. 5 and 6. So B union C is 3, 4, 5, 6. So n of B union C is 4. So that is equal to 12. So n of A cross B union C is 12. So with the same information, another question can be asked. So if the question is something like this, find the number of common elements in A cross B union C and B union C cross A. So we have already seen that A cross B union C contains 3 into 4, 12 elements. And obviously if you reverse this, B union C cross A also contains 4 into 3, 12 elements. Now the question is, how many of these two elements are common? How many of these two elements are common? So find the number of common elements in this and this. So this depends on the property 5 that we have learned. So when a question like this is asked, this is the first set, this is the second set. And here the sets are being reversed. So what is the fifth property? If the first set and the second set have n elements in common, then first set cross second set cross first set has n square elements in common. So to find the number of common elements, just need to find the number of common elements in A and B union C. So we know that A is 1, 2, 3. B union C is 3, 4, 5, 6. So how many common elements are there in A and B union C? So number of common elements is nothing but 1, right? Because you have only 3 in common. So you have only 1 common element in these two. So what is the number of common elements in the crosses? Is nothing but 1 square, which is same as 1. So out of these 12 elements, there is only 1 element in common for these two. So if I ask the question in English, because you have the property in English, so you can very easily relate. Sometimes to confuse you, so what will be given is, they just try to frighten you. So if I ask the question, n of A cross B union C intersection B union C cross A is equal to how much? So if I ask this question, so do you see that this question is exactly same as this question? What is the meaning of this? Number of elements in the intersection of these two. What are the elements which come in the intersection of these two? Common elements. So the question asked is the number of common elements in this and this. The answer for this will also be equal to 1. So the next question is, express graphically the Cartesian product of n cross n, I cross I, integers cross integers, integers cross real numbers, and real numbers cross real numbers. So you're asked to express these sets graphically. So now let us take the first set, natural numbers cross natural numbers. So this is nothing but the set containing ordered pairs A comma B, such that A comes from natural numbers and B also comes from natural numbers. So now if you take A as 1, B can be 1, 2, 3, 4, so on. So you get points 1, 1, 1, 2, 1, 3, 1, 4, so on. And next 2, 1, 2, 2, 2, 3, 2, 4, so on. Right? So if I write this in diagrammatic form, it looks something like this. 1, 2, 3, 4, so on. 1, 2, 3, 4, so on. So you get all the possible matchings. You get all the possible matchings. So in diagrammatic form, this set looks very clumsy. So let us try to express this in graphical form, which will be neat. So what are the points that you have? Let us write the grid points 1, 2, 3, 1, 2, 3, 4, so on. So first you have 1, 1, this point will be there, 1, 2, 1, 3, 1, 4, 2, 1, 2, 2, 2, 3, 2, 4, 3, 1, 3, 2, 3, 3, 3, 4, 4, 1, 4, 2, 4, 3, 4, 4, and this extends up to infinity in the first quadrant. So n cross n represents all the grid points in the first quadrant. So I hope you understood this. So n cross n graphically represents all the grid points, that is the intersections of vertical grid lines and horizontal grid lines in the first quadrant. Next, if you go for I cross I also represent the grid points, but this time integers can be negative, 0 or positive. Similarly, y coordinates can be positive, 0 or negative. So when you go for I cross I, apart from this, you also get the grid points on the axis. These will be there. and along with them you also have the grid points of the negative quadrants also. First, second, third, fourth, all the quadrants. The grid points of all the quadrants. So all these grid points combinedly form the set, this I cross I or Z cross Z, right? So you get all these grid points. Right? So you get all these grid points. So all these grid points combinedly constitute my I cross I. Now in the third set you're asked to find I cross R. That is, the first element, the x coordinate of the point has to be an integer, but the y coordinate can be any real number. The y coordinate need not be integer. So if you take 0 as the x coordinate, y coordinate can be anything. The y coordinate doesn't need to be discretely 1, 2, 3, 4, so on. So this time if you want I cross R, you get all the points on this line, so you have to draw this line. And correspond to x is equal to 1. You get all the possible y's, so you get a line here, instead of discrete points. So now you get discrete lines. So I cross R will be represented by the series of vertical grid lines. So all the points on these vertical grid lines come under I cross R. And if you want R cross R, that means you want the point such that the first coordinate is a real number, the second coordinate is a real number. There is no limit. It need not be any particular number. So if x is real and y is real, then you get all the points in the coordinate plane. So R cross R represents all these points in the coordinate plane. So R cross R represents Cartesian plane. So from now on, instead of saying Cartesian plane, I can also represent Cartesian plane as R cross R. So you should understand that R cross R represents the Cartesian plane. Thank you.